All right, so what have we seen and where do we have to go? We've solved a linear supply and demand model to find the equilibrium price and quantity. And even better, we have found the equilibrium price and quantity if we have taxes, right? And if we have the solution for taxes, you just make a negative tax and you get the solution for subsidies. We're about to look at price controls, and then we'll look at quantity controls. But within these scenarios where we're thinking about aspects of these problems, we want to think about what sort of information we can pull out of the model. So we've built the model, we've solved for some equilibria. There are more details that we can pull out. Importantly, details about total surplus. So especially finding the dead weight loss, that's going to be the classic question, but we might ask questions more specifically about producer surplus, right? This would become important if we're thinking about, say, rent seeking. Consumer surplus for other reasons, thinking about the benefit of some good, trying to get a better estimate of its real impact on well-being, not just what we can pick up in the price alone. In any case, let's jump over to price controls. So we got two kinds, a price floor or a price ceiling, and this is a binding floor, but if we lowered it, it would be a non-binding floor, right? A minimum price of $1 for an SUV isn't a price floor that matters because no one was going to sell an SUV for less than $1 anyways. We just have the equilibrium at whatever the price is, right? Likewise, a ceiling that is too high is non-binding. But when the ceiling gets too low, then we run into problems because we can no longer coordinate the wishes of buyers and sellers through the price mechanism. So let's think about how we could make this model. Well, let's just jump into it. Let's say we've got a price ceiling. I'm going to call this P max, because ceiling is a little confusing, especially given our ceiling is lower than we're used to. So let's just say our P max is, let's call it X. That'll be fine. So if P max is less than P star, let's go ahead and find what P star was. That was from way back. AD plus BC plus BD. Then we got Q star. All right, so P star equals AD BC all over, I think it was B plus D. Sometimes I write it D plus B, but it doesn't matter. Then we're going to have our actual quantity is going to be less than Q star, and I'm just going to copy that formula again, C minus A over B plus D. All right, so if P max is less than P star, where P star is this number, right? So whatever X is, if it's less than this, then we are not going to get to our equilibrium quantity, right? So we're just sort of adding a conditional element to this. This is, I guess, kind of an if-then. This is a little throwback to logic. All right, so we've got a quantity. Now what can we do with it? Well, in that case, our price, well, let's lay out what we know. So we're going to have some price, and that price is going to either be AD plus BC over B plus D, and that's going to be the case if X is greater than P star, AD plus BC over B plus D. Or we're going to have the price X, that maximum price, otherwise. Right, so if X is equal to this, then we have a price that is that. But if we have, basically, if this point is higher than this maximum price, then we have this. And our quantity, again, we can say is going to be C minus A over B plus D if the same thing, right? If this, and otherwise, what's our quantity going to be? Our quantity is going to be the quantity supplied. So where was our quantity supplied? Let's try to save on this. Quantity supplied P minus A over B. So P minus A, where P is going to be X minus A over B. So our quantity is either going to be our equilibrium quantity, or it's going to be whatever price we get, or sorry, whatever quantity we get that corresponds to a price of X being applied to the supply curve. So this is a slightly more elaborate way of describing this market, but these two conditions, right? We get the one thing if we have this, right? If we have the same thing, our quantity is the equilibrium quantity if our price ceiling is high enough, and otherwise it's going to be what we get from here. Now this is sort of a little bit more formal than we really need. What are we going to be asking about this? Well, we're almost certainly going to be asking about dead weight loss. So our dead weight loss, the key there is going to be finding the relevant numbers. And those relevant numbers are what happens to our quantity, right? So as we go from the equilibrium quantity to this, and what happens to the gap between the demand curve and the supply curve at that quantity. So this, it's easy enough to set up, but this might take a little bit more work, but let's go for it. So delta Q is going to equal Q star minus something, right? Or is it going to be something? It's going to be something minus Q star. We're going to end up with a negative thing. So minus Q star, and what are we subtracting from? Our quantity is X minus A over B, right? Our equilibrium quantity given a binding price ceiling, minus the quantity we would get without that ceiling, which would be C minus A over B plus D. All right, that's not too bad. Getting these points, well, we've already got this. That's just going to be X, but how far do we get? Essentially what we want is we want to pull from the demand curve. We're going to plug in Q. Ooh, where are we? Where did it disappear? Here we go. Our demand curve, A plus BQ. So we want to find the price corresponding with the quantity that we're getting here. So let's just call this A. A is going to be equal to that price, which is A plus, oh, I already used A. N, M, let's call it M. Good enough. So M is this price, which equals A plus BQ, which is equal to A plus B, and the Q that we get if we've got the binding price ceiling, this is going to be X minus A over B, all times B. Ooh, that's convenient, isn't it? So those B's are going to cancel. We get X, or sorry, A plus X minus A. That just equals X. That seems wrong. Oh, I plugged that into the supply curve. So what I want is C minus D times X minus A over B. So that's why it's good to have some number sense. I mean, you could follow the procedure exactly, but most of the time there isn't a procedure to follow. In this case, we could make up a procedure, but that would just make it boring. So we're going to have C minus all this stuff. Let's see, can we get rid of that B? We got some M, well, whatever it is, right? It's this. That would just be BM. That doesn't help. Well, I'll just simplify, right? So I got C, and actually, you know what? I'll even call it BC so that I can put it all over B. So BC over B is the same as just C, minus dx plus AD. All right, that's a little bit easier to read than this, but it's the same information. So M, that is the height. That is the marginal benefit of the unit of good that we're not getting because our quantity supplied is restricted. Now, this is under the best case scenario where the only people who are getting it are people who value it at some level greater than M. They would be willing to pay more than M dollars for the few units of this good, even if they're only allowed to pay X dollars. So we found one of our key points. This key point we're calling X, so that's easy. And we've got delta Q. So now we just throw that all together. Can we simplify this at all? It doesn't really look like it. I guess we could multiply so we just have one thing over some other thing. But I think that's just going to make it more complicated than we need to. So let's focus on what we do have. What we do have are some figures that we can just plug numbers into. So this would be a good point if we had a specific system, specific values of A, B, C, and D. Maybe just plug those in here now, right? So we get M, we subtract that from our price ceiling of 20 or whatever it is, right? And we get that change in height. And let's do this in red just to make it explicit. Dead weight loss. This is going to be 1/2 times delta Q, which we've got over here. Again, we can just plug in those numbers, times M minus X. I guess M minus X we could do, so let's just say this isn't M, this is M. And let's try to do, oh, sorry, no. That was M when I was doing the supply curve. This is M. This is X. X does, in fact, equal X. But M equals this mess here. And if we subtract X off of that, we could subtract, say, BX over B, which is just the same as subtracting X, which would give us M minus X, which gives us the height of our triangle. Do we get anything fun out of that? I guess we can, combine the dx with the bx, but, well, let's see, what do we have? We've got AD plus BC minus X. I guess this would be minus X of B plus D. I think I'm getting that right. All over B. So then we take that is this term here, we multiply it by this, and that's going to be a little bit of a mess. Maybe it resolves nicely, but again, this isn't going to be compelling stuff to watch on a recording, so we'll call it there. Now, what happens if we're looking at a price floor? Well, we're basically going to be flipping that from a greater than to a less than. Then instead of looking at the supply curve, we're going to plug in the demand curve, right? But we're just swapping out parts, and we're going to be going through the same procedure. We're then going to be, plugging, what would it be? I guess it would be X minus C over negative D. We would be plugging into this equation, into the A plus B, right? And that would give us what is our equivalent to M. right? So this price floor, it looks like it's kind of touching at M. So let's just pretend like it is. So if M was our price floor, we would solve this and we would get X out of that if we just happen to have this price floor that just happened to be at the same level as our solution to that part of the price ceiling problem. All right, so what am I saying? To get from a ceiling problem to a floor problem, we're just flipping some stuff out. This becomes less than, this becomes the demand curve rather than the supply curve. This is still exactly the same, right? So we're still going to be subtracting the same stuff. We might accidentally lose a negative sign, but this is a case where it doesn't really matter. We're still going to be doing something along these lines, but just with different parts in a different order. We're still going to be doing this, right? And all of this is going to be giving us this triangle. So what's so special about this triangle? So with this price ceiling, we restrict our quantity. We restrict the size of the market to this point, right? And I actually kind of like that this ended up nice and symmetrical, because this is going to essentially give us the same logic behind a quantity restriction. If we restricted quantity to this level, we would also have this dead weight loss. Now, this is the guaranteed dead weight loss. This must be the case, because compared to what's optimal, compared to what we would get if we only had people buying who valued it above a price, and that price was above the price at which people were selling, and people were only selling if the price was high enough, right? We get this nice maximally efficient outcome without price controls, right? Assuming no things like externalities, which is where we'd want to bring in a tax, not a price control. So given this restricted quantity, what does that mean? Well, the best we could get out of this would be to give these restricted units to the people who get the most value out of them. So let's think about, say, a price ceiling on gasoline after a storm. We want that gas to go to the ambulances, right? And to people who have to check on their elderly relatives. We don't want that going into a generator that's running so that I can play some PlayStation, right? That would be a low valued use. So let's assume it only goes to the high valued uses. We'd get this total benefit from that limited amount. And again, thinking best case, what is the lowest opportunity cost for getting there? Well, in the case of a price ceiling, we're not going to get anyone else to supply except here. But here are the low-cost suppliers, so we net that out, and we're left with total surplus in this trapezoid. Right? So if we have that best-case scenario, then we get this total surplus, we miss out on this, and this is our dead weight loss that we must necessarily have from a price ceiling, or a equivalent price floor, right? A price floor that restricts quantity to the same level. In that case, only these buyers will be able to buy, because the price will just be too high for me to justify buying the gas to run my generator, right? The sellers, on the other hand, might be different, right? In this case, with this price floor, we're going to have a restricted quantity, but there's no guarantee we have the lowest opportunity cost sellers, because this seller would like to get this high price. This seller wants it more, right? Because they have a bigger potential producer surplus, but there's still no guarantee that this guy doesn't get there first. All right, so let's stop here, and then we'll come back to the question of how this might get worse.